well sufficiently informed. So we have 4x squared plus 1 equals 4x. So my first move, I'm going to bring the 4x over. All right. So if I do that, we have to have it in descending order. It should be 4x squared minus 4x plus 1. Equals 0. And we're doing this using the quadratic formula, so we want to identify the a, b, and c values. So here's my a. I'll just move that up. A, b, and c. All right, so x is equal to negative b, so negative parentheses. I know this seems like kind of a wasted step, because you could just plug it in, but people screw up the part that's under the radical so frequently that I kind of default to this every time, just to help you avoid making that mistake. And it all has to do with the parentheses. It's every single time. All right, so b squared minus 4ac all over 2a. All right, so negative b, so negative 4 squared minus 4 times 1 over 2 times 4. All right, so this is a nice, crisp, clean 4 plus or minus rad 0, which is 0, over 8. All right, square root of 0 is equal to 0. The additive identity tells us that you can add or subtract 0 to a number and you're not going to get any change. So 4 plus or minus 0 is equal to 4 in both cases. 4 minus 0 is 4, and 4 plus 0 is 4. It's no more complicated than that. So 4 over 8, result 1/2. So in many cases, we end up with 2 possible roots when solving a quadratic. Here we only end up with 1. In the next unit, we'll see what that looks like graphically, but it is possible to have no solution, 1 solution, or 2 solutions. All right, you can't have more than 2 solutions though. And so that's what that table is all about. And that's related to what's known as the discriminant. The discriminant is just the expression under the radical. So there's no real learning here in terms of operations. You know, it's the same skill. The b squared minus 4ac is the same stuff that you've been working on. Right? It's just we're only focusing on that part of the quadratic formula. All right? Based on what emerges from that computation, you can get a sense of what kind of roots you're up against. All right? In a lot of cases, this is sort of a recipe to give you a sense of what the best approach is for solving your quadratic, because we have, at this point, 3 possible avenues. We have a factoring approach, we have completing the square, and we have the quadratic formula, right? Any of those 3 could be fair game. So thinking forward to the test, I could ask you to solve a quadratic using a particular method. Right? Or I could say use a method of your own choosing. Right? If you opt to use the discriminant, you can get a sense of what the best approach would be, right? Based off of the outcomes here. So 2 real rational roots. Right? You see something like that, it's like, okay, that's just math terms, math words, math vocabulary. But what does it mean? Well, rational it's really defined by what it isn't. It doesn't have a radical in it, right? So those are clean numerical answers, all right? So we're looking at something that's factorable. All right? If you have rational roots, regardless of what kind they are, it means that your original quadratic is something that can be factored and solved. All right, so it generally tells us that we're not wasting our time to try to factor it. Now, there is the other side of that coin where you would say, well, if I already figured out the discriminant, which is the part under the radical in the quadratic formula, aka the most complicated part, why not just go to the distance and use the quadratic formula? I mean, there is merit to that thought. My answer to that is there are some concepts down the line that are going to require you to know specifically the discriminant. So there's a little bit of what you can use it now for, and then there's, what is it going to be used for down the line, and that's a recurring theme in this course. The one real rational root, that's the beautiful one. What that means is not only is it factorable, but it's also a perfect square trinomial. Perfect square trinomial, a PST. All right, and so that tells us that what we started with originally could have been factored using the perfect square trinomial factoring technique, which is one of the easiest kinds of factoring techniques. All right, now you go back to that do now problem and you see that we had only one real root, one real rational root. Right? By the way, if it's rational, it's got to be real anyway. Right? Same thing with irrational. They're all a subset of the real number system. But what it tells me is, going right back to this guy here, I could have looked at it and said, all right, take the square root of the first term, 2x, square root of the last term, 1, carry down the middle sign, and write it as a power of 2. All right, it's like completing the square, but the square is already completed. So all the hard work in completing the square is already done. So then the next step in this process, if I were to solve it using algebra rather than the numeric process of completing the square, would be to take the square root of both sides, 2x minus 1 equals 0. Solve this linear equation by adding 1, 2x equals 1, x equals 1/2. So it's kind of nice. The discriminant gave us that. It gave us a sense of what we were up against, right? But you wouldn't necessarily know that unless you compute the discriminant, right? So the discriminant computation. If you look at what we did in the do now, all it is, and so I'm not going to waste too much more of your time. All it is that expression under the radical. So when we got the 0 under the radical here, that was our discriminant. So that would fall into this category. B squared minus 4ac is equal to 0. One real rational root, factorable by perfect square trinomial technique. All right. So these are the types of numbers, I'll highlight them for you, that you're looking for. A number that's greater than 0, a number that's less than 0. I'm sorry, number that is greater than 0. I can't talk anymore for some reason. I guess it's because it's Friday. And a perfect square, a number that's greater than 0 and not a perfect square. Being greater than 0, greater than or equal to 0, that's where my brain was going, guarantees that it'll be a set of real numbers. Less than 0 is the case where it would be imaginary or no real roots. So in terms of the least amount of work, finding a discriminant that's negative is great, because that's just telling you, I'm done. I don't have any work to do. There's no real roots, right? So that's kind of a nifty little byproduct of all of this, right? So let's just do number 1 together, and then I'll set you loose. So still identifying the A, B, and C values, but this time I'm only focused on B squared minus 4ac. So basically what we've been putting in the calculator this whole time, All right, so the B squared, AC. All right, so negative 2 squared minus 4 times 10 times negative 9. All right, so negative 2 squared, you could figure that out by hand if you want, but the reason why, again, I do the parentheses is so that it's ready to be typed directly into the calculator without any additional thinking required. So 364. Now, this is not a case where we have to break down the radical or break down a value because it's not a radical, right? I'm only looking for the value that's under the radical. I just need to know if it's a number that's positive in a perfect square, positive and not a perfect square, 0, or negative. Well, I know it's not 0, and I know this number is not negative. So the only question would be, is this number a perfect square? And it's not. So this is a number that is positive and not a perfect square. Therefore, 3 dots in the form of a triangle means therefore we're looking at 2 real irrational roots. All right, and you see the directions says use the value of the discriminant to describe the number and type of roots for each equation. So the discriminant, we got that, 364. It's implied, I mean, I didn't label it, but it's implied. What else would it be? I gave the number of roots, 2 of them, and the nature of them. These are the type of roots, real, irrational. I didn't put the commas, so 2 real, irrational roots. All right, so covered all the bases, got everything we needed. All right, and that's all these questions are asking you to do for the most part. You know, down the line, you'll be expected to do something with this information, but for now, you know, just to get started, all you're asked to do is figure out what the discriminant value would be. All right, so you have the remainder of the period. That's a lot of time for a fairly simple process. So pages 48 to 50 is what you're doing.
So the reason it's the 2 real irrational roots is because it's greater than 0 with a discriminant, but it's not a perfect square.
Correct.
Okay.